For this module, we're going to learn about the exponential function and log functions as well. You will see that those two functions are closely related. The first problem I want to do is we need to know how to graph the exponential function. So it's important to know the graph, and it's also important to know the domain and the range as well. So you can see that right here for graphing exponential function, there's no trick to it. You're just gonna get a graph like this or this one. So you can see that right here, what I have is a fraction for the base. So it's really hard to find a number and try to make it into a whole number. So I just pick 0, 1, -1, 2, and -2 for x and solve for y and plot the points. Of course, you need to know that this one right here is a y-intercept. For exponential, it's always going to be like that. Now, exponential application problems, we often talk about the compound interest. So every time you see the word compounded, we have to use this formula right here. Hopefully you get it memorized. A is the final amount, P is the initial amount, rate, R is for rate, T is for times in years, and N is the number of compounding period. So for example, if we have a problem compounded monthly, that means N is 12. So it's compounding 12 times. Okay, so you see for number 2, it's really straightforward. I just plug it in. So 6,000 is P, which is the principal. Rate is 3% over N. N is 1 because it's compounded each year, so one time. Just like number 2, number 3, exactly the same because we have compounded annually. So that's why N is 1 right here. I was hoping for something a little bit harder. So this one right here, we see is compounded quarterly. Therefore, we have 4 here. Okay, so 4 here for quarterly, so 4 times a year. Notice that when you use your calculator, make sure you make this into 24 before you use your calculator. If you use a good scientific calculator, you probably can punch it in. But if your calculator is not that great and you don't see everything on the screen, make sure you follow the order of operation. Okay, now let's take a look at number 5. This is the model of exponential function. This is a model. We just need to know what is the initial price. So the initial price in this case is 1400. That's P right there. Okay, now how do I know if the function represents growth or decay? You see right here, I have 1.053 to the t power. So this one is greater than 1. So if it's greater than 1, it's the growth. It represents a growth function. If it's less than 1, then it's decay function. What percent the price change each year? That's gonna be the number. You subtract 1. That's the percent. So the percent right here is 0.053, but that's decimal. So if you want to change it into percent, it's going to be 5.3%.